Hello everyone, for this tutorial video I would like to explain more precise measurements related to magnetism, as mentioned somewhat in the last tutorial video, as well as explain how it is similar to formulas for resistivity or capacitance. We will see unfortunately, however, that unlike resistance or capacitance, there are actually two valid international unit systems for magnetism and not simply one. Although magnetism is the only international scientific unit that is like this. Every other electrical detail, like almost for resistance, is always one specific standard. As mentioned in the last tutorial video, there is a magnetomotive force, which means the severity of the magnetic effect, analogous to voltage for circuits. The field flux, which is the overall quantity of the field, similar to current. But there is also field intensity, which means the amount of field force distributed over the magnet itself. Flux density, which means the amount of magnet force concentrated in a specific region. And something known as reluctance, which is the opposition to generating a magnetic field, analogous to resistance. And then lastly, like there is resistivity for resistors, there is permeability for magnets. Although the catch is permeability is used in the opposite manner as resistivity, namely that the effect is stronger with more permeability, whereas current was weaker with more resistivity. The two international measurements you will see for field force are amps per turn and something called the Gilbert. Similarly, the units you will see for field flux are Maxwell's and Weber's, and for field flux intensity you will see Oersted's and amps turns per meter. For field density, you will see Gauss and Tesla. For reluctance, you will see Gilbert's per Maxwell and amp turns per Weber. And lastly, for permeability, you will see Gauss per Oersted and Tesla meters per amp turn. As you can probably imagine, the relationship between magnetomotive force, flux, and reluctance is similar to Ohm's law, and is expressed using the same exact formula but with different symbols. And the formula for reluctance of a magnet is similar to resistance of a wire, which is length over cross-sectional area. But the twist here is that permeability is in the denominator and not the numerator, because of what was mentioned earlier in the video, that permeability means less resistance, which might make intuitive sense if you know what the word permeate means. The big problem with magnets, however, is that they do not have a simple relationship between electromotive force and reluctance as suggested in the formula, because the reluctance is not constant, but changes depending on the flux. In my next tutorial video, I'd like to talk about how saturation is related to permeability, and how saturation is an important concept when choosing what the core of your magnet is.
Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.